Students, in previous video we have been seeing some of the operations on graphs that are related to subgraphs and all. Now here also we have to see some of them that we have to learn now. First, complement of a graph. Now what is complement? Is the opposite part, we can say. The complement, it will be denoted by G bar. Of G is a simple graph with same vertex set as G, where two vertices U and V adjacent in G bar, also only when they are adjacent in G. Now, for example, suppose this is a graph. Suppose V1, V2, V3, V4, V5, V6. Suppose I will draw such a graph here. Let it be G. Then what is G bar? Here same vertices are there. V1, V2, V3, V4, V5 and V6. But the edges, which are these? So all these edges given here are not there. So simply here are the edges. Which are they? Not present in that one. Those edges will be here. This is G bar. Okay. So here I can say G bar is a complement of graph G. Okay. Now here note. So first, complement of the complement of the complement of the graph G is G. That is, G bar of bar is what? G. Second, complement of a complete graph, is a null graph, and vice versa. Means a complement of null graph is what? A complete graph. Third, complement of a regular graph, complement of a regular graph is regular. If G is K regular, then G is K regular, suppose with n vertices, then G bar is n minus K minus 1 regular. G bar means its complement is n minus K minus 1 time regular. That's the degree of that one, right? Let Kn be a complete graph, Kn be a complete graph on n vertices, and G be any graph on n vertices. G be any graph on n vertices, then number of edges in G, number of edges in G plus number of edges in G bar that is equal to n into n minus 1 upon what? 2. These are nothing but number of edges in Kn, right? This is about the complement of a graph. Now next thing, self-complementary graph. Self-complementary graph. Now what it is, if a simple graph G is isomorphic, if a simple graph G is isomorphic with its complement, isomorphic with its complement G bar, then G is called a self-complementary graph. So let me give an example here. V1, V2, V3, V4, V5. Now here V1, V2, V3, V4 and what? V5. So here this is what? G bar. But these are what? Isomorphic to each other. Here there is an isomorphism between them. Fine. But note, in a self-complementary in a self-complementary graph G on n vertices n or n minus 1 or n or n minus 1 must be a multiple of what? 4. This is important here, remember that. Now further part we have to see the other operations: union, intersection, ring sum, product and fusion. Now let's see them one by one. So for that let me write, if G1 is V1 E1 and G2 is V2 E2 are two graphs, then first union, suppose union of G1 and G2, what it is, right? Union of G1 and G2, it is a graph G with vertex set V and edge set E, suppose, where vertex set is what? V1 union V2 and edge set is E1 union E2. It is denoted by what? G1 union G2, right? Second, intersection of G1 and G2. It is a graph G with vertex set V, edge set E again, where V is what? V1 intersection V2 and edge set is what? E1 intersection E2. It is denoted by G1 intersection G2, right? Next is ring sum of G1 and G2. It is a graph GVE again, where what is V? Is V1 union V2 and what is edge set? Edge set is E1 union E2 minus E1 intersection E2. That is what? G1 ring sum G2, this is a notation for it, equal to G1 union G2 minus common edges, of it. Now let's write few notes on these. So first, G1 union G2 is same as G2 union G1. G1 intersection G2 is same as G2 intersection G1, right? G1 ring sum G2 is same as G2 ring sum G1 also. Okay. Second, if G1 and G2 are two edge disjoint graphs, then G1 intersection G2 is phi and G1 ring sum G2 is what? G1 union G2. If intersection will be phi there, so no common edges are there. Fine. Third, if G1 and G2 are two vertex disjoint graphs, then simply G1 intersection G2 is what? An empty set. Fourth, for any graph G union G is same as G intersection G, and that is G itself, and G ring sum G will be what? An empty set. Then next one, if H is a subgraph of G, then H is subgraph of G, then G union H will be G. What about G intersection H will be what? H, and G ring sum H will be G minus H. From G, simply remove edges in H. From G, remove only edges in H. This is a part about union intersection ring sum. Now let's see example, a common example in all these. Example, consider two graphs and find G1 union G2, G1 intersection G2 and G1 ring sum G2. So G1 and G2 are here. So now solution. G1 is what? V1 E1. Where what is V1? Is a set. Look at how many vertices are there? 5. V1, V2, V3, V4 and V5. Right? And what about edge set? E1 having 6 edges. A, B, C, D, E, F. Right? These are. Similarly, G2. I can say and. G2 is what? V2, E2. Where V2 is what? V1, V2, V3, V6 or V5, V6. And edge set E2 is what? A, C, H, G and what? L. Okay. KL, HG, K and what? L. Fine. Now what is G is what? G1 union G2, suppose first. Let it be VE. First part. Where what is V? is V1 union V2. It will be V1, V2, V3, V4, V5 and what? V6. These one. And what is E? It is E1 union E2. It will be A, B, C, D, E, F. A will be not again. C will be not again. C is between V2, V3. It's same. H, G, K and what? L. Simply. So simply we have to combine those graphs. So the resulting graph will be V1, V2, V3. Suppose here as such. Wait, let me give name to the vertices first. V1, V2, V3, let it be V4, V5 and V6. Okay. So now look at here. A is the age between V1 to V2. B is age between V1 to V3. This is A, B. Fine. Next, C is the age between V2 to V3. C is there. D. D is age between V2 to V5. So this is D. Then next, D. E will be age between V3 to V4. So this is E. Then F. F is an age between V5 to V4. So this is F, right? Then H. H is an age between V1 to V6. H. G is an age between V1 to V3. So this is a G. Then this is V3, V6. K. And L is between V6, V5. This is L. This is what? G1 union G2. Fine. Similarly, let's find G1 intersection G2, G1 ring sum G2. Second part, G1 intersection G2. So for that, what is V? Is V1 intersection V2. Intersection in between them is what? V1, V2, V3, V5. Okay. And what is age set is E1 intersection E2. And what it is? Simply A and C, right? So let's write first 4 vertices: V1, V2, V3, V5, right? Now A and C. So A is between V1 to V2. This is A. And C is between V2 to V3. This is C. This graph is what? G1 intersection G2 simply. Now third part is what? G1 ring sum G2. It is G1 union G2 minus common ages. Minus common ages. That is G1 union G2 minus what? A and C. And now just we have found G1 union G2. So simply remove A and C from there and write down the remaining one. So this is V1, V2, V3, V4, V5 and V6. So that graph will be as such. this is V1, V2, same one I am drawing. You can see in your notebook if you have written, obviously. These are here E, A I am not drawing, and C I am not drawing. This is V1 to V6 will be H. This is B and G. Here it is K. This is L. This one V4 to V5 F, right? And V2 to V4. V2 to V4. Now there is no H in between these. Sorry for that. Okay. So this is a graph. This is what? G1 ring sum G2. This one more edge is left here. This is D. This is D. Okay. This is G1 ring sum G2. Fine. Now next term we have to see about a fusion of a graph. It is a fusion of a vertex. So fusion of vertices. A pair of vertices A, B in G are said to be fused, merged, or identified if the two vertices are replaced by a single new vertex such that every edge that was incident on either A or B or on both is incident on the new vertex. Hence, by definition, the fusion of two vertices does not alter the number of edges but the number of vertices is decreased by 1. Example, let GV, this graph, let it be V1, V2, V3, V4, V5 and V6. E1, E2, E3, E4, E5, E6 and E7. Okay. Now suppose we fused two vertices V2 and V5. So I am considering them as 1. So V2 and V5 are 1. So V1, here simply new vertex I am writing. V2 as well as V5 is that. Here V6 as it is. Suppose here this is V1, V3 and V4. V3 and V4. Now there is an edge between V1 and V2. So I will write this is E1. Right? There is between V2 and V3. So this is E3. Then there is an edge between V2 and V5. So it is a loop. It will be a loop. Sorry, it is not directed. Right? This is E2. Now there is an edge between V5 and V6. So it is E7. V5 and V4. So this is E6. Then there is an edge between V3 and V4, E5. And there is an edge between V3 and V5 also. So this is one more edge, and that is what? E4. As such, we can do the fusion here. This will be a fused graph. This is original G, and this is a fusion of these two vertices will be done. So whatever edges are incident on those vertices, you should draw all of these. So now edge set will remain same, but the vertex set is decreased by 1. Now the next thing we have to see the product of two graphs. Product of two graphs definition. Let G1 is V1 E1 and G2 is V2 E2 be two simple graphs with V1 intersection V2 is an empty set. The product of G1 and G2 denoted by G1 product with G2 is the graph having vertex set as V is V1 cross V2. Then U is suppose U1 U2 and V is another one V1 V2 are adjacent in G1 cross G2. Whenever U1 equal to V1 and U2 is adjacent to V2, or U2 equal to V2 and U1 is adjacent to V1. Let's take an example. Suppose This is u1 u2 with an age e6. This is graph g1, suppose. Or let's eliminate an age. Suppose this is v1 v2 v3. Let it be graph g2. Then g1 cross g2, you know, here 2 vertices, here 3 vertices, so this must have 6 vertices, right? So A, B, C, suppose D, E and F. Now, and how does the ages are how many? Here these are as such. Ages will be as such. This is G1 cross G2, where what is A? It is U1 V1. B is U1 V2. C is what? U1 V3. D is U2 V1. E is what? U2 V2. And F is U2 V3. As such. Okay. So this is all about the introduction to the graph. Here our first chapter of graph theory is finished. In next video I will start a chapter 2, that is connected graph. But before going towards that, I will declare that I will conduct a test on this chapter 1. Thank you.